Alright everyone, this is section 13.6. In this last section of chapter 13, our goal here is to be able to solve triangles using the law of cosines. The last section we talked about a different way to solve a triangle using the law of sines, and that was for any triangle that was not a right triangle. And this still applies, that if we don't have a right triangle, we could still use the law of cosines now to solve that triangle. So the law of cosines, we're going to let triangle ABC be any triangle with side lengths A, B, and C representing the measure of sides opposite the angles with measures angle A, B, and C respectively to those sides. Then the following equations are going to be true. We're going to have side length A squared equals side lengths B squared and C squared added together, and we're going to subtract out 2 times the side length B times side length C times the cosine of A, and then the other two variants down below, if depending on what kind of side length we're going to be solving for and what kind of information you're given about that triangle. So in example 1, let's try to apply that. We have this triangle ABC, and we're supposed to find side length A, given that side length C is 8, side length B is 10, and the measure of angle A is 60 degrees. Okay, so we're going to try to figure out what we're going to solve for. Well, that's A. Okay, so we know we need to solve for A, but we know B and C. So we're going to use the B squared plus the C squared minus 2BC cosine of A. We're going to use that one. Okay, and that looks bad. Let me redo that. So cosine of A. Okay, so let's plug in what we know. Well, we don't know A yet. We do know side length B, which is 10, so 10 squared, plus side length C, which is 8 squared, minus 2 times side length B, which is 10, times side length C, which is 8, times the cosine of our angle A, which was 60 degrees. Okay, so we got A squared, and we're going to type that on the calculator. So 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of angle A, which was 60 degrees. And that does give us 84. And now we're going to take the root on both sides to get rid of that square on the A. Okay, so A, when we do that in the calculator, is about 9.2 because we can't really break that apart using any perfect squares. So A equals about 9.2. Now we're going to find example R given triangle QRS. So when they have different kind of vertices other than A, B, and C, I like to just rename them A, B, and C. So QRS, let's call them A, B, C. Now it's kind of like solving for triangle ABC. Okay, so if we look here, I know side lengths, and that's about it. Okay, so what we can do now, if we're trying to solve for R, or we're really calling it B, we can use to solve for B. So that formula. So minus 2AC this time, cosine of angle B. Okay, so since we know technically B, aka R, that side length, we're going to know that 23 is little b, so squared, plus little a or q is 37 squared, plus little c, aka s, is 18 squared, minus 2 times 37 times 18 times the cosine of angle B, and we're trying to figure out angle B, aka angle R. Alright, so I'm not going to really try to start solving or evaluating quite yet. What I'm going to do first is kind of move by subtraction this stuff over to the other side. Okay, so I'm going to subtract both of them. So 23 squared, that was still over there, minus 37 squared minus 18 squared is equal to negative 2 times 37 times 18 cosine of b, aka r. Okay? And now what I'm trying to do is kind of isolate that cosine of b. So I could do that by dividing both sides by negative 2 37 times 18 on both sides. Okay? So now I'm left with cosine of b, aka r, is equal to 23 squared minus 37 squared minus 18 squared all over negative 2 times 37 times 18. So what we're going to do now is put that in the calculator. So 23 squared minus 37 squared minus 18 squared all over negative 2 times 37 times 18. And we do get a decimal, that is 0.738, or if we round to the thousandth, 0.874. It's about 0.874. But we want the angle, so what we're going to do is take the inverse on both sides. So cosine inverse of 0.874. So inverse cosine of 0.874, and we'll get the angle, which is about 29 degrees if we round it to the nearest degree. So we have that angle R is about 29 degrees. So in this second one here, I had 3 sides, the 18, the 23, and the 37. So that was a side, side, side triangle. And if you notice back up here in our first example, we had a side angle side. Okay, side angle side. Excuse me. Now in example 3, solve triangle KLM, round angles or angle measures to the nearest degree, and side measures to the nearest tenth. Okay, if we look here, I have a side and an angle and another side. So again, this is a side angle side. Okay, so if we try to figure out, let's say K is first, okay, to get that side length. So I'm going to use K squared, and it's going to equal, let's say, L squared plus M squared minus 2 LM cosine of little k, or big K, which is actually 51 degrees that we'll plug in here. So we don't know K yet, because they're trying to solve it all. Our little L, side length L, is 18, so 18 squared plus M, little m is 14 squared, so minus 2 times 18 times 14 times the cosine of angle K, which is 51 degrees. Alright, so we're going to plug all that in the calculator. So So 18 squared plus 14 squared minus 2 times 14 times 18 times the cosine of 51 degrees, and we get about 202.8. And we're going to have to take the root of 202.8 here in a second, and we're going to get about 14.2. So k squared was about 202.8. And if we rooted that, k was about 14.2. So we know all three side lengths now. Now we're going to try to figure out what the angles are. Okay, so now if I'd say want to figure out angle L, for example. Okay, so angle L, well, I'm going to need to do angle L here squared is equal to our angle M, or side length M, squared plus K squared minus 2 times M and K cosine of L that we're trying to figure out. And I'll make that a capital L. Alright, so now we know that side length little l is 18, side length little m is 14, and little k is now 14.2 squared. So we'll fill that in. And we're trying to figure out the angle of L. So we're going to do like we did before, where we got the cosine of big L, and it's going to equal 18 squared, and we're moving over the 14 squared and the 14.2 squared. Then we had to divide it all over negative 2 times 14 times 14.2. So that's where the calculator is coming in. So 18 squared minus 14 squared minus 14.2 squared. All over negative 2 times 14 times 14.2. Okay, and now we're going to have to take the inverse cosine of that. So 0.185, let's say, to the thousandth. And we're going to get 79.3 for angle L. So again, we had to take the cosine inverse and that was of 1.85 or 0.185, excuse me, on both sides. And we got that cosine or angle L is about 79.3 degrees. Alright, so angle L is 79.3 degrees. And the last thing we could do is add those two angles together, L and K, and subtract it from 180, because the whole triangle is equal to 180 degrees. So 79.3 and 51 degrees is 130.3. degrees. So when we subtract those, we get 49.7 degrees. And that's equal to angle M. So 49.7 degrees. And now we have solved the whole triangle. We now know all three angles and all three side lengths of that triangle. All right, in example 4, we're going to do the same thing. So now we know all three sides. So all three sides. So this is again a side, side, side. Okay, so since we know all three sides, we're going to try to figure out some of the angles. Okay, so let me start out by writing X, Y, and Z as angles. I'm going to figure those out. Little x is 45 inches. Little y is 51 inches. And little z is 38 inches. All right. Let's say we want to figure out angle x. Okay. So angle x, I'm going to start out with little x squared is going to be equal to y squared and z squared minus 2 y and z. And then cosine of angle x that we don't know. But we do know little x is 45 squared, and little y is 51 squared, and little z is 38 squared, minus 2 times 51 times 38 times our cosine of x that we don't know yet. We don't know that angle x. So again, we're going to solve for angle x. So that's 45 squared minus 51 squared minus 38 squared all over negative 2 times 51 times 38. So again, let's put that in the calculator. So 45 squared minus, not multiply, 51 squared minus 38 squared all over negative 2 times 51 times 38. So 0.521, and we're going to need the inverse cosine of that, 0.521, and we're going to get 58.6 for angle x. So that was of 0.521, and we took the inverse of that, cosine inverse on both sides. And we got angle x to be 58.6 degrees. All right. And now we're going to do the same for angle y. Okay. So now we know we need to find angle y. So little y squared equals little x squared plus little z squared minus 2 times x times z times cosine of angle y that we don't know. Okay, so we do know little y, that is 51 squared, little x is 45 squared, little z is 38 squared, minus 2 times 45 times 38 times cosine of angle y that we don't know yet. Okay, so we're going to do the same kind of process to figure out angle y. Well, we're going to start out with 51 squared, and we're moving 45 squared over there with it, and subtracting 38 squared too, all over negative 2 times 45 times 38. So the cosine of angle y is about, and as we put that in the calculator, so 51 squared minus 45 squared minus 38 squared, all over -2 times 45 times 38. So about 0.254. And we need to take the inverse of that on both sides. So cosine inverse to make the angle. So angle y is about, so the cosine inverse of 0.254 is about 75.3 degrees. So 75.3 degrees for angle y. Okay? And the last thing we need to do is just figure out angle z. Well, we know 2 of the angles out of 3. So one more time, once again, we could do 180, which is the sum of all angles in the triangle, and subtract out 58.6 and 75.3, which is 133.9 degrees. And when we subtract those, we get 46.1 degrees. That is equal to angle z. Okay, so 46.1 degrees, and that has all 3 angles and all 3 sides for our triangle here. So we solved the whole entire triangle. The last thing we're talking about is the area formula through the law of cosines here. S is actually equal to 1/2, and we're adding up all 3 of the side lengths here. And we're going to use that in Heron's area formula, which is the root of that S value subtracted from a series of all 3 of those side lengths multiplied together. So in our last example here for chapter 13, and in this section, we're going to find the area of a triangle that has these side lengths of 170, 200, and 350. So let's just call these side lengths A, B, and C. Because first, what we need to know is that S value. And that formula was 1/2. Then we added up A, B, and C. Okay. So I'm taking 1/2 and adding 170 plus 200 and 350. So we can do that in the calculator. So 1/2, and we're adding 170, 200, and 350. And we got 360 back for that S value. Okay, so S is equal to 360. That's the important part. Now, in order to get the area, I'm plugging it into the bigger formula. So the square root of S, and then S minus A, S minus B, and then S minus side length C. So the area is going to be equal to 360 times 360 minus side length A, which is 170, times 360 minus side length B, which is 200, times 360 times side length C, which was 350. Okay, so if we look at this, that is the same thing whenever we reduce this down as 360 times 360 minus 170, which is 190, 360 minus 200, which is 160, and then 360 minus 350, which is 10. So now we could put that into the calculator, like so. So we need a big square root, and we need 360 times 190 times 160 times 10. Okay. And if we round that off, let's say to the 10th, that is 10,461.4. So 10,461.4, and since we're working in units that we don't know, I'll just say units squared and squared because we're working in area. So 10,461.4 units squared. And that might seem like a big number, but you got to think back to, again, your triangle side lengths are bigger numbers, like 170, 200, and 350. So this answer does make perfect sense here.